So, okay, I think we just skip this for a while. Let's go to do the lecture first. Okay, now see the software cannot be used for timing. So we take a break from the software. For so long, I haven't really encountered computer stop because these days computer very good, right? I think personally also the computer now very with all the advanced processor, this is nothing really. Okay, let's go. Let's go to look at this. Download block. Okay, let's look at this one. Okay, the last lecture. But actually this one, some of the topic, of course, as I mentioned before, some of the topic, important topic will be in the final. Some topics may not be in the final. Okay. Okay, this one will next week. That's a joke. Okay, let's go through the multinomial logic model, right? Okay, so first, generalized linear model, GLM. Okay, general linear model. In practice, there are many different types of response variable, including binary, win or lose, right? Just now we mentioned 1 or 0, right? Nominal, Democrat, Republican, or third party candidate, nominal, ordered, so 1, 2, 3, 4, 5, and so on. So there are many examples of generalized linear model. The broader class of model that generalize the multiple linear relation. So recall we learned the logistic, right? The logistic relation or logic function. Okay, remember just now the logic function. Given this, y equal to 1 or y equal to 0, the probability is this is equal to p, this is equal to 1 minus p, right? Okay, so this is your odds. Okay, so we can estimate the p by solving the logistic equation. Okay, suppose we consider this is the probability here. We can estimate the probability by solving the logistic equation. Else this is your probability hat, right? Suppose we consider y is equal to 0 as the baseline category, such as p probability of y equal to 1 equal to p, and y equal to 0 equal to p I0. Then the estimated logistic regression is this one, log this one equal to this, and regress against beta naught and beta 1x. Interpretation, beta 1 satu. When x increases by 1 unit, the predicted odds of y equal to 1 versus baseline multiply with a factor of exponential beta 1. So you get this, you must exponent, right? So this is the so-called how many times, okay? The odds, okay? The odds, right? How many times? If it's more than 1, likelihood to happen, right? Likelihood to occur more than 1. If less than 1, chances are it will less chances to happen, right? So beta naught when x equal to 0, beta naught is the intercept, the predicted odds of 1 versus the baseline 1 to 0. Okay, next one is multinomial logic, right? Multiple logistic model. Sorry, any question? What's one? We are looking at the slide, right? Okay. Multinomial logistic model, MYR is similar to logistic model, but the difference that the target dependent variable can have more than 2 classes. So I say mention 1, 2, 3, 4, 5. Okay, I think I did mention roughly last week. So it's called multi-class or polycotomous. So I say how you come to school, 1, walking, 2, by public transport. Okay, 2, bicycle. Okay. Anyone come to school by bicycle? No, right? Not environment friendly. Come to school by bicycle? Very good.
Thank you.
Okay, number 1 is walking. Walking. If you stay in the dormitory, you can walk, right? Okay. Public transport, maybe number 3. MRT, I don't know, LRT, MRT. Okay. So these are different mode of transport, right? Okay. And the last one maybe by car, right? The most unfriendly one, and very unfriendly. Okay, just a joke. Okay. Okay. Modular logistic. Okay, the model, right? So MR is used to model nominal outcome, right? In which the logs of the outcome are modeled as a linear combination of predictor variables. Suppose the response y is categorical, takes a value 1, 2, equal to k such that k bigger than 2. Okay? Multinomial distribution, right? You have actually variable x, then we want to fit a model such that y equal to k. Probability k is a function of x. So you have a baseline model. In the ML model, we have a separate equation for each category or respond to the baseline category. If the response had k possible, then k minus 1 equation as part of the ML model. Okay, so they got different equation. Suppose we have a response variable y that can take 3 possible outcomes, then coded A, B, C. So let A be the baseline model. Hypothesis for the beta. So let's say the model is this. So you are testing beta k equal to 0, beta sub jk not equal to 0. Right? So this is using z test, right? Okay, p-value, okay, standard normal, confidence interval, prediction. So prediction k category, right? Exponential divided by 1 plus. Okay. This is similar to one we learned earlier, right? Exponential, right? Can we just scroll back? Yeah, this is right. Can you see? It's similar to this, huh? The probability. Okay. And for the baseline category equal to k equal to 1, the probability is. Okay, so example 1. People's occupational choices might be influenced by parents' occupation and their own education level. We can study the relationship of one's occupation choice with level and education level and father's occupation. The occupational choices will be the outcome variable, which consists of categories of occupation. Okay, so this is study. One kind of study you can do. Okay, number 2, food choices of alligators might capture the interest of biologists. It is possible that adult alligators exhibit distinct preferences compared to their younger counterpart. In this context, the type of food would serve as an outcome variable. Okay? Okay, so types of food serve as an outcome variable. Just now, occupational choices is the outcome variable. While the size of alligator and the various environmental factors could be considered predictor. Okay, size and also the environmental factor. Okay, next one. Entering high school, students make program choices among general program, academic program, vocational program. Okay, so when a student enter high school, you may choose academic, vocational, general program. Okay, academic vocational. Their choice might be model using the writing score or the social economic status (SES). Okay, the score, right? Score 1, 2, or 3, right? Okay, this experience data. The data set contains 200 students. The outcome variable program. The predictor is SES 3-level categorical, and also writing score, right? Writing score. Okay, so this is your type of program, and this is your SES. Cross-tabulate. Cross-tabulate means you try to find the so-called what they call it, relationship. Most time is a categorical one. Categorical data. Okay. If you are continuous data, we just use correlation, right? Yes or no? If the continuous data, we use a correlation, Pearson correlation. This one is a categorical. This one we covered in the step 2, right? Step 2 at the last part. Still remember our step 2? In fact, our step 2 covered a lot of things. I think this we cover a lot. We try to cover so many steps 2. Right? Okay? So relationship between categorical, so that means your SES score, low, middle, and high, and then your type of program, general, academic, and vocation, right? Okay? Most of the time, I think in the high school or university now, I think there are some sort of category, right? When people admit students, right? Because I think not because of they want to do that. I think because they want to make sure the student who enter the program can do well, for example. Okay, I think not because if you look back, it's not because they want to, sort of like, oh, don't allow certain people to come. No, I think most of the time it's because when the student come in, whether they can cope with the studies. A lot of times, sometimes students enter, after 2-3 semesters, they can't even achieve 10 credit, for example, because they always fail the subject. Okay, there are cases for our master's program. We found that there are certain students that cannot cope with the subject, right? And then sometimes they are sort of like, they have to stop the program, right? Okay, they cannot continue. So it's a waste of time and energy. You come in for 1 year, you cannot achieve anything. Okay, let's continue. So this one you use chi-square. This one actually is covered in your, as I mentioned, in step 2, the statistic 2. Okay, chi-square. So Pearson, chi-square, right? Chi-square. We run the model in expressions, we specify the baseline group to be the academic group, base equal to 2. Okay, general vocation. Then we write the models, right? So this is beta naught, beta 1, beta 2, 1, beta 3, 1. Okay, you substitute, for example, here 1.689, 1.689, 1.6116. It's all here, right? This is the answer, right? And then you have this 4 point, this is another one, right? This is another, okay, this is another group, okay? Okay, interpretation. Okay, so now let's look at interpretation. Beta 0, 1, right? Beta 0, 1, 1, 1. Okay. Okay, so let's look at this one. A unique increase in variable right is associated with the decrease in the log odds of the general program versus academic program in the amount of 0.058. 0.05. This one, the writing score. Okay, this way, this is the one. I think this, okay. Next one, the unique increase in the variable right is associated with the decrease in the log score of vocation program versus academic program in the amount of 0.0114. Okay, 0.01 is here, 0.014. Okay, next one, the log odds of the general program versus academic program with the increase of 0.63 if the moving from high to the middle. And the next one, the log odds of the general program versus academic program will increase by 1.163 if moving from high to low. Okay, 1.163. High to low. Okay, and so forth. I think this is all is there. Okay. Next one, we look at the prediction. Okay, observed versus predicted frequency. So this is same thing when we calculate. I think in the stats 2 we also calculate that the O minus observed minus expected squared divided by divided by expected. Okay. Then you add up all the category. Okay, I'm not sure whether you still remember or not. So example of case 1, writing score 31, SES low, and type program is general. So you calculate, you get 0.30. So there's a 30.98% probability of choosing general program for high school students with writing score of 31 and low socio-economic status. Okay, so you next one, calculation case 2, writing score 31 and socio-economic score is 1, type of program is vocation. So you calculated, you have, this is calculated probability, right? Because exponential this divided by 1 plus all this, okay? All the beta, exponential all the beta. So there is 58.22% probability of choosing vocation program for high school with writing score 31 and low socio-economic status. Okay, so the last one is case 3. Case 3 is the overall. So there is a 10% probability of choosing academic program for high school students with writing score 31 and so low socioeconomic status. Okay, so how to interpret the R square? Okay, how is R square calculated for logistic? Logistic regression model are fitted using the maximum likelihood. Okay, maximum likelihood method. The parameter estimate are those values which maximize the likelihood of the data. R square cannot be computed in the same way. So pseudo R square are used. Pseudo means not the real R square. Pseudo R square by the name. When the outcome is nominal or ordinal. Okay, ordinal, nominal. However, it's important to note interpreting the magnitude R square in logistic is different from linear regression. In logistic, the interpretation of R square is not as straightforward because dependent variable is binary or categorical. McFadden pseudo R square is a measure of goodness of fit of logistic regression model. It ranges from 0 to 1, indicates the proportion of variance explained by the model. It does not represent the proportion reduction in error as R square in the linear regression, right? Proportion of reduction in R square. This one is proportion of variance being explained by the model. Variance is basically the changes, measure the changes. It is based on the log likelihood canals or intercept only model and the full estimate model. McFadden R square measure bounded by 0 and 1. Okay, so this is the. Okay, let's look at other types of pseudo R square. Cox and Snell R square is based on the log likelihood. Compare the log likelihood for the baseline. However, with the category outcome, it has a theoretical maximum value of less than 1, even for the perfect model. Okay, so this R square, also known as Craig-Euler, is an adjusted version of Cox and Snell R square that adjusts the scale of statistic to cover the full range from 0 to 1. Okay, so there are three types of pseudo R square, right? The McFadden is what we see in the E-views, right? The model explains around 11.8% of variance in the program. Okay, and last one is the model fitting. Likelihood ratio of chi-square 48 here, 48.23 with a p-value of less than 0. Tells us model is significant and better than the empty model with no predictor. Okay, so this is basically multinomial logic. Okay, unless you use it, if not, then later when you need it, you come and refer. Okay, this one I hardly see in any. Normally in economic model we don't really use as much. This is not really that. We normally use logic and profit, but also this is one of the model available for you to use. Okay, let me see the E-views. Oh, so totally up. Okay, I think probably I need to shut down and then restart again. That's the only thing. Okay, now before that, let's go back to look at the tutorial. Okay, look at tutorial 12. Okay, let's go to tutorial 12. Okay, so we have okay, good and bad. We got 2 questions. Okay, but we need the E-views, right? Okay, so then let's go through and see whatever we can do. Unless I shut down and on again. Look at this solution. Okay, we already have the output. Okay, let's read the. Okay, let me try to close some. Can I close some? Restart. You want to restart? Okay, let's restart. Okay, let's restart. 6, no need to restart, okay? Okay, but I need to log in again.